Right. So the topic of this lecture is Fft algorithm, and we'll see how it can be implemented. And the best way to see how it can be implemented is actually to apply it to a sequence of a given length. So we'll see Fft algorithm. And we will start with n equal to 8. What I mean by that is that one xn is given to me in form of a sequence with sample points x0 to x7. So this is given to me. They're separated, and the task is to find sk to be evaluated using Fft algorithm. So that is the task. I can write it something as follows: xn dft 8 points gives sk, and we have to do this, as I said before, using Fft. So this is the task in hand. So now n is equal to 8, capital N is equal to 8 is 2 to the power 3. So as mentioned before, 2 becomes the radix and 3 becomes the number of stages. So in this case, a radix is 2 and a number of stages is 3. And in a previous lecture, I had mentioned that what we'll do is that we would have considered 8 points. They will be divided into 4 and 4 points. Then these 4 and 4 points will be subdivided into 2 points, 2 points, 2 points, and 2 points. So this will constitute stage 1. This will constitute stage 2, and on this side, so this is fundamentally like this. This will constitute stage 3. On this side, you will have your inputs xn in some fashion and order, and on this side you will get your xk's in some fashion and order. So this is fundamentally how we will be working. So we'll work as stage by stage. So in this video we'll focus on stage 1. So first stage, as I said before, the first stage is something like this. So we have the 8 points So we will have something x0. This is ultimately the goal, to evaluate these values. x3, x4, x5, just a second. x6 and x7. And over here, if you remember, we had a stage where we had blocks of 4 points and 4 points. So the input that is going to this 8-point block is something like this. You have 4 outputs of this block going as inputs to this block, and you have 4 outputs of this 4-point block going to input as this block. So we are going to look into what is happening here in stage 1. Okay, stage 2 will come later, but stage 1. So I have divided these points accordingly into 4 halves, 2 halves of 4 points each, and let's see how we can work with that. So as I said before, your xn is fundamentally a sequence from x0 to x7. This sequence xn I can divide. Of the various ways in which I can divide it into 2 equal halves, I divide it into 2 halves in such a way that one half has even evenly located, I must write evenly located samples, and second half has odd located samples. So this is what I do. I say let Gn comprise of all the even location points, and I denote it as x2n, and here n varies from 0 to 3. So that means there are 4 samples, and if you put n equal to 0, you get x0, which is this point. If you put n equal to 1, you get x2, which is this point. If you get n equal to 2, you get x4, which is here, and if you put n equal to 3, you get x6, which is here. So we have picked up all those sample values of xn which were located at even indices for xn. Similarly, the odd indices are picked up in another sequence called hn, and this sequence would then become 2n plus 1, and here also your n would vary from 0 to 3. So we had initially a sequence where n was varying from 0 to 7, which had 8 sample points. I have divided that sequence, small xn, into 2 sequences gn and hn, where gn comprises of all the sample points of xn which were located at even indices of n. and I've made this sequence, and Hn has been made an odd index points being picked up from Xn, so that becomes Hn. And you can see, if you put n equal to 0, you get x1, n equal to 1, you get x3, n equal to 2, you get x5, n equal to 3, you get x7. So these are the two sequences, and the length of these sequences is, or r, length of the sequences are, individually they are of 4 units. Okay, so looking at the definition of the DFT, so I have to evaluate these values over here, and the inputs are basically the transform values for Gn and Hn, right? So on this side I have fundamentally G0, I have G1, I have G2, I have G3, and here I have H0, I have H1, I have H2, and I have H3, right? So now basically I have to express xk in terms of G's, capital G's and capital H's. So let's see how we can do that. The definition, conventional definition of xk is xn wn kn, and in this case our n happens to be 8. So instead of capital N, I will write it as 8, and here your k varies from 0 to 7. The same way n varies from 0 to 7. So this I can bifurcate into two halves, one with even index values and the other with the odd index values. So this becomes n is equal to 0 to 3. You have xn 8kn plus n is equal to 0 to 3 xn w8kn, and these are basically your even index values being picked up, and these are the odd index values being picked up. So the even index values, so you have n is equal to 0 to 3, this can become x2n w8 2kn plus n is equal to 0 to 3 x2n plus 1 w8 2n plus 1k. So what I've done is that I've replaced n by 2n in the first sequence here, in this sequence, and then I've replaced n by 2n plus 1 in this one, because they represent the odd index sample points, and correspondingly the changes have come in the powers of the twiddle factor w8, right? Now x2n, we all know that in the problem is basically gn, and there is a property of twiddle factor which says that wn square is wn by 2 to the power of 1. So in our case, so if I just write it somewhere here separately, so w8 to the power 2 becomes w4 to the power 1. So this can be written as w4 kn plus, if you see over here, w8 to the power k can come out of the summation sign because the summation is over n, so you get w8 to the power k out here, and then it is summation 0 to 3, and this becomes your hn, and this becomes w4 nk. Now if you look at this structure and this structure, then they simply represent the conventional DFTs of Gn and Hn evaluated over 4 sample points. So I can write this as Gk plus W8k Hk, where I can say that Gn is DFT over 4 points, which gives you capital Gk, and Hn, if DFT is evaluated over 4 sample points, you will get Hk, right? So then I can say that capital Xk is Gk plus W8k Hk. Now here your k varies from 0 to 7, right? But then if you look at this very closely, there is no problem when you evaluate x0. So that will be basically G0 plus W80 H0. You will calculate x1, which will be G1 plus W8 H1, capital X2, that will be G2 plus W82 H2, capital X3 will be G3 plus W83 H3. But now if suppose you were to evaluate capital X4, then that will be G4 plus W84 H4. Now here there is an issue. The issue is that because Gk is defined only for k value ranging from 0 to 3 and Hk is defined only for k value 0 to 3, then how will you obtain the value G4 and H4? So even though this expression is valid for the entire duration for k, which is 0 to 7, we have to find out a way to ensure that we can find the values of capital X4 to capital X7. And if we just use G4 to G7 and H4 to H7, we cannot find it out because we don't have those values in Gk. So what do? We also know the solution to this is as follows. We know that Gk and Hk are both periodic. With a period of 4, which means that G k plus 4 is basically Gk. We know that Hk plus 4 is Hk. And there is another property of twiddle factor, which means that W8 to the power k plus 4 is fundamentally minus W8k. This comes from the property that if you have an n-point DFT and you have on the power k plus n by 2, then this becomes fundamentally minus W8k. It's a standard property and you can always derive it, but we will exploit that rule over here. So I can actually write xk, so instead of writing, so here what I do is that instead of k, I write k plus 4 everywhere. So I write x xk plus 4 becomes gk plus 4 plus w8 k plus 4 hk plus 4. So this can be written as gk minus w8k hk. So this becomes capital Xk is gk plus w8k capital hk, and here instead of taking it from 0 to 7, I take it only to 0 to 3 because I have only values of gk ranging from g0 to g3. But I write in the next step, exploiting the periodicity property, xk plus 4 minus w8k hk, and here also it ranges from. So I have divided that 0 to 7 range of xk into two equal ranges of 4 samples each, where I express xk as a certain expression and I express xk plus 4 as another expression. And now all the values follow. x0 is 0 plus h0 plus this would be a 0 1 h1 x2 is going to be g2 plus w8 to h2, x3 is going to be g3 plus w83 h3. Now in the second expression here, if I put k equal to 0, I will get x4, which will be g0 minus w80 h0 is going to be x5 is going to be g1 minus w81 h1 x6 is going to be g2 minus w82 h2 and x7 is going to be g3 minus w83 h3. Right. So that ways I have written all the DFTs capital X from 0 to 7 in terms of capital G's and capital H's, which range from 0 to 3. This model, in the next video, I will try to represent in some sort of a model which is often known as butterfly model. So this is the first stage, and the first stage ends here. And over here what we have done if you see, we have found out the values of capital X0 to capital X7 in terms of G0s to G3 and H0s to H3 by exploiting the periodicity property of capital G and capital H and some properties of the twiddle factor. This is K. Alright, thank you.